Hello, today we're going to work on 7.6 rational exponents. So since rational means any number that can be written as a fraction of two integers, we're talking about exponents that are fractions. Now if we look at b to the m over n, we have the exponent m over n. That is going to be equivalent to the nth root of b to the m. Notice here that the numerator of the exponent is the exponent under the radical, and the denominator is the index. So being able to write it in either form is going to help us simplify different problems various ways. So let's take a look at a couple of these examples here. So you can see numbers 1 and 2 are done for you. You can see the square root of 9 in radical form is equivalent to 9 to the 1/2. So there is no exponent here, so you can always use 1 as a placeholder. That's where that 1 is coming from. And then with radicals, if there is no index, that is an implied 2 using the same logic. So looking at number 2, you can see the fourth root of z is equivalent to z to the 1/4. For number 3, if we have 64 to the 1/2, that means we are looking at the square root of 64 to the first power. So you can see that the 1 and the 2 are implied. So the eighth root of c could be written as c to the 1/8. The cubed root of c to the -5. C is our base, -5 is our numerator, and 3 is our denominator. Again, the index is your denominator. For number 6 here, a to the 1/5 power would then be the fifth root of a. So for the rest of these, you can either try them yourself or keep going with me. Either way is fine. So for number 7, x to the 3/4 is the fourth root of x cubed. Number 8, -216. Negative 216 has to be in parentheses here because that entire quantity is being raised to the 1/3 power. For number 9, we are looking at the fourth root of 16 to the 5th power. Number 10, you have 81. You have 4 as your denominator, and then 3 is going to be your numerator. If you wrote it as 81 to the 1/4 cubed, that would eventually get you to the same spot. Now for 11, you end up with 81 to the 3/4 power as well. So since both of these are equivalent to each other, sometimes it might be nice to write it in one form or the other to simplify or work with, depending on what the problem is asking us to do. So now that we can go back and forth between radical form and exponential form, we can use that to help us solve problems. So let's look at examples 1, 2, and 3 here. In their current form, we really look at that and say, well, we don't really know how to solve that. So they're all in exponential form. However, if we were to write this in radical form, number 1 would be the cubed root of 125 to the first power. Now, if I gave you that problem walking in the door, you'd look at that and say, hey, I can break down 125. That's going to end up being 5 cubed, so the cubed root of it is just 5. So in its radical form, we could deal with it. In its exponential form, we could not. So we had to move it to its radical form. So let's take a look at number 2. It's going to be a similar idea. In its current form, we can't do 81 to the 3/4. This is not 27. It's not saying take 3/4 of 81. That's important. What it is saying is it's saying take the fourth root of 81 and cube that. Now, you could do this in either order. You could do 81 cubed first and then take the fourth root of that, but I don't know anyone who knows the 81 cubed right off the bat. So instead, I'm going to do the fourth root of 81, get an answer, and cube that. So the fourth root of 81 is 3, and now I can take that answer and cube it to get 27 as my final answer. Now 3 has two problems with it. First of all, it's in its current form, which we can't really deal with. The second problem is this negative exponent. So any negative exponent is going to take and move that to the denominator, and it's going to become a positive exponent. So this becomes 1 over 49 to the 3/2. Now that we've taken care of one of our issues, let's take care of the other one. We're going to go ahead and write the square root of 49 cubed. So we're in radical form. This is going to become 1 over 7 cubed, which is going to be 1 over 343. And if you wanted to test this out, you can take out your calculator and type in 49 to the negative 3/2 and verify that it is 1 over 343. So we need to be able to do these problems without our calculator, but we can use it to help check our answers. So radical form is great for simplifying numbers, but exponential form will be great for using our exponent rules. So we have all of our different exponents here. We know that if we have the same base and we're multiplying, we actually add the exponents. A power to a power multiplies. You have to distribute your exponents when it's in parentheses. We just talked about negative exponents, moving them down and everything like that. The division here is subtraction. And anything to a power, you have to distribute that power to everything if it's a monomial. And anything to the 0 power is 1. Now, the m and the n, you're used to being just integers. They can be positives, negatives. You can add, subtract, multiply them, divide them. We are now going to start making them fractions. We're going to make them rational numbers. So you're going to treat them just like you normally would if they were nice numbers. You're just going to have to add, subtract, multiply, and divide them as fractions. So looking at this one, 3/7 and 2/7, you're going to add those together and get 3 to the 5/7. 1/2 and 1/3, we're going to take and multiply those to get 1 over 6. We can distribute rational exponents to different bases with monomials. We can take rational exponents and move them into the denominator if they're negatives. We can take them and subtract them. Now, these all happen to have common denominators, but if they don't, we would have to find the common denominators. So let's go ahead and use that to solve a couple of these problems here. So for number 4, we have x to the 4/5 and x to the 6/5. So what we're going to do is we're just going to say, if this was x to the 4th and x to the 6th, you no doubt would just say x to the 10th right away. So you're taking and you're adding your exponents. So we're going to do the same thing. We're just going to do 4/5 plus 6/5. So this is going to become x to the 10/5. And that is going to then simplify to x to the 2nd power. So now let's look at number 5. Think about what would you normally do with a power to a power. We would normally multiply. So now we're going to go ahead and multiply. 3 times 2 is 6. 3 times 4 is 12. And then we're going to reduce wherever possible. Now, this gives us y to the 1/2 power, which is the square root of y. These two are the same. In general, though, whatever form your problem started in, you want to end in that same form, unless the problem specifies otherwise. So this problem started in exponential form, so I'm going to answer in exponential form, unless I'm asked to do otherwise. So let's look at the next one, 1/2 and 1/3. Normally we would take and subtract these. So we're going to do 1/2 minus 1/3. So we actually have to find common denominators now. So they both would have a common denominator of 6. We're really doing 3/6 minus 2/6. So we get x to the 1 over 6. And we're going to leave it in exponential form. Lastly, we have number 7. So we have x to the negative 1/5 here. This negative sign means we have to move this to the denominator. Now, at this point, it looks like we're not breaking any rules. However, if we were to transfer this into radical form, we can see that we are actually breaking a rule of division. You can't have a radical in the denominator. So we have to rationalize this. The 5th root means we are looking for groups of 5. Right now we only have one x, which means we need 4 more to get a complete group of 5. So this is going to become the fifth root of x to the fourth over x. Now, normally we would circle this and say this is our answer, but our original problem started in exponential form, so we need to transfer this back into exponential form. So my numerator would be x to the 4/5, and my denominator would just be x. These two here are equivalent, but we're just now in exponential form. So for problems, what I'm going to recommend doing is I'm going to say whatever form you're in, can you simplify in that form? If not, you're going to change forms, meaning exponential, let's spell exponential right, exponential to radical, or vice versa. Then you're going to try to simplify in that form. And if you do and keep going, then you're going to go ahead and try changing forms back. And you're going to keep on going in this cycle until basically you can't simplify no matter what form you're in. Then you just need to make sure your answer's in the final form that you need. Okay, so that's kind of your process, because sometimes you can simplify in exponential form when you can't in radical form, and vice versa. So let's take a look at some examples where we're going to have to go back and forth between the different forms. Let's take a look at number 8. So in this current form, we look at this and we say we can't divide this. 16 divided by 2, yeah, I know that number, but the problem is that the 6 and the 3 are different, so you cannot divide when they're not the same index. So instead what we're going to do is we're going to write this in different forms. So 16 to the 1/6 and 2 to the 1/3. Now, this once again looks like you can't do anything to it. However, 16 is not a prime number. So any composite number, I'm going to break down and write with exponents instead. So 16 is 2 to the 4th power. So we're going to do 2 to the 4th power being raised to the 1/6 power. Now we have a bunch of simplifying that we're going to have to do. So 4 and 1/6, that's going to simplify to 4/6 when we multiply it. And then 2 to the 1/3 is the denominator. We're getting closer because we have 2 to the 2/3 and 2 to the 1/3. And now we are actually going to be able to reduce this, only because we have the same base. So 2 is our base, meaning we're going to take the exponents then and subtract them because it's division. So 2 to the 2/3 and 2 to the 1/3, when I subtract them, gives me 1/3. And then I'm going to say, okay, my original problem was in radical form, so I need to answer this in radical form. This is the cubed root of 2. So to recap, we started in radical form. We could not deal with that. We changed it to exponential form. We also changed any number that was not a prime number into a different form to help us deal with that. And then we used our exponent rules and changed back to radical form. So number 9 is going to be somewhat similar to that. 27 is 3 to the 3rd power. And the 4th root means it's 3 to the 3/4 power. The denominator would be 3 to the 1/2 power. So where we originally could not divide because it's not the same index, now I've made them have the same base. So my base is 3, and I'm going to do 3/4 minus 1/2 and get 1/4. This is equivalent to the 4th root of 3. So I'm going back into radical form to answer that question. So looking at number 10, likewise, we cannot multiply these because this is the cubed root, and then we have the square root. So we're going to have to change these into exponential form and also break them down. So I'm going to let you do that. Rewrite these in exponential form and write them as their prime factorization, and then come back in video 2 to see the answer.